Hi dear students, in previous video we have discussed about theorems on calculation of residues. So here in this video we move on to some problems regarding calculations of residues. So here first example is find the residues of the function z divided by z square plus 1 into z minus 1 at different ports, and hence evaluate this integration over c z divided by z square plus 1 into z minus 1, where c is modulus of z is equals to 2. So solution like this. Solution of this problem is like this. Let f of z is equals to z divided by z square plus 1 into z minus 1. Right? Now we need to find different poles of f of z, which are as follows. So consider this denominator z square plus 1 into z minus 1 is equals to 0. So equate to 0. This implies z square plus 1 equals to 0 or z minus 1 is equals to 0. So here we'll get the poles z is equals to plus or minus I or z is equals to 1 will get. Therefore the poles z is equals to I, minus I and 1 are simple here and lies inside C. So how it lies inside C? Let us see by diagrammatically here. So consider this is a region, right, and this one is C with radius 2, with radius modulus of z is equals to 2, right? So here the poles are I, minus I, 1. Suppose minus I is here and I is here and this is 1. Therefore I, minus I and 1 are lies inside this C. That is what modulus of z is equals to 2. Modulus of z is equals to 2. So therefore by theorem 1 we have residue of f of a is equals to limit as z tends to a, z minus a into f of z. So here residue of f of I, one by one we need to calculate residue of these poles. So first consider f of I at z is equals to I, we need to calculate the residues. So residue of f of I is equals to limit as z tends to I, z minus I into z divided by z plus I into z minus I into z minus 1. So if you multiply these three quantity, we'll get as it is z square plus 1 into z minus 1. So here z minus I and z minus I are get cancelled, will remains with, and apply the limit over here, will get 1 divided by I divided by 2I into I minus 1. So that means if you put z is equals to I will get, next here 2I will get, and next here I minus 1. So therefore I get cancelled, only will remains with 1 divided by 2 into I minus 1. So next step is we need to find out the residue of the next pole. So here the next pole is minus I. Therefore residue of f of minus I is same procedure you need to find out as in this step what we have done, same procedure we need to do. So after doing the same procedure, we'll get f of minus I, residue of f of minus I is equals to this quantity. So minus 1 divided by 1 divided by, minus 1 divided by 2 into I plus 1. Also, residue of f of 1 is equals to 1 divided by 2. So therefore, by Cauchy's residue theorem, we have integration over C f of z into dz is equals to, so this is our formula, 2 pi I into residue of f of a's. So here different poles are there, so therefore you need to combine the values of residues of f of a. So 2 pi I into residue of f of I, right, plus residue of f of minus I plus residue of f of 1. So this is equals to 2 pi I into 1 divided by residue of f of I is 1 divided by 2 into I minus 1, and residue of f of minus I is, so here minus 1 divided by 2 into I plus 1 plus 1 by 2. So 2 pi I into 1 divided by 2, if you take common 1 divided by 2, what will remains, and if you take LCM, this I plus 1 goes with this, cross multiply I plus 1 minus I plus 1, next here minus 1 minus 1. So I square will get I minus 1 into I plus 1 will get here. So I minus 1 into I 1 is what? I square minus 1. So I square value is minus 1. So therefore we have taken I square as minus 1 here, directly we have taken, and next minus 1. So I plus 1, I minus 1 is the denominator. So if you multiply, 2 and 2 are get cancelled, pi I into 0 will remains, the value of this function is 0. Residue of that function is 0. So next example, consider the second example. Evaluate z plus 4 divided by z square plus 2z plus 5 into dz, where C is a circle defined by modulus of z plus 1 minus I is equals to 2. Same procedure we need to follow as we have done in the previous example. Consider f of z is equals to z plus 4 divided by z square plus 2z plus 5. Here we need to find out the poles. Consider this denominator and equate this denominator equals to 0. So here this one is quadratic equation. It is in the form of quadratic equation. So therefore z is equals to what we got? Minus 1 plus or minus 2i. So therefore z is equals to minus 1 plus 2i minus 1 minus 2i are simple, and here minus 1 plus 2i is lies inside C. Why? So here they are given modulus of z plus 1 minus I, they are given is equals to 2, right? So here only this pole lies inside C. Therefore we need to find out the residue of this minus 1 plus 2i only. So therefore residue of f of minus 1 plus 2i is equals to limit as z tends to minus 1 plus 2i into z minus into bracket minus 1 plus 2i into f of z. So here this quantity and this quantity are get cancelled, only will remains with, if you apply the limit, only will remains with 2i, right? 2i plus 3 will get here. So if you put z is equals to minus 1 plus 2i, will get 2i plus 3 divided by 4i over here. Therefore by Cauchy's residue theorem, integration over C f of z into dz, f of z into dz is equals to 2 pi I into residue of the function residue of f of a. F of a means minus 1 plus 2i is the pole. So here 2 pi I into residue of this f of minus 1 plus 2i is 2i plus 3 divided by 4i. Put this in this equation. We'll get I are get cancelled. 2 1s are 2 2s are pi by 2 into 2i plus 3. So this completes the solution of the second problem, right? Consider the next third problem. Evaluate integration over c z into e raised to z divided by z square minus 1 into dz, where modulus of z is equals to 2, where modulus of z is equals to 2. Let solution of this problem. Let f of z is equals to z into e raised to z divided by z square minus 1. Therefore, the poles are z square minus 1 is equals to 0. It means what? Z is equals to plus 1. So, therefore, the poles are minus 1 and 1 are simple and lies inside C. So, what they have given C? Modulus of z is equals to 2 they have given, with radius 2, circle with radius 2. So therefore minus 1 and 1 are lies inside C. Therefore residue of f of 1 is limit as z tends to 1, z minus 1 into z into e raised to z divided by z square minus 1. So if you apply the limit z tends to 1, so here z minus 1, z into e raised to z divided by this quantity can be written as z plus 1 into z minus 1. So z minus 1 are get cancelled, only will remains with z into e raised to z divided by z plus 1. So if you apply the limit z tends to 1, means if you put z is equals to 1, what will get? 1 into e raised to 1. That means e and divided by 1 plus 1 will get e by 2. So the next example, sorry, not example. So we need to find out the residue of another pole, right? What is another pole? That is minus 1. So residue of f of minus 1 is equals to limit as z tends to minus 1, z plus 1 into z into e raised to z divided by z plus 1 into z minus 1 is there. So therefore here z plus 1 and z plus 1 are get cancelled, minus 1 is there. If you put z is equals to minus 1, here minus 1 will get, e raised to minus 1 will get, divided by minus 2 will get. So this implies 1 divided by e I can write down, divided by 2. So minus are get cancelled, only will remains with 1 divided by 2. Therefore by Cauchy's residue theorem, integration over c z into e raised to z divided by z square minus 1 into dz is equals to 2 pi I into residue of f of 1 plus residue of f of minus 1 is equals to 2 pi I. So into residue of f of 1 we have already e by 2 plus 1 divided by 2e is equals to f of 1 by 2 e we have is equals to e square plus 1 divided by e will remains here. So if you take 1 by 2 outside, 2 are get cancelled, only will remains with e plus 1 divided by e. So this I can write down directly, e plus e raised to minus 1 into pi I. So this is the residue of the given function. So here some assignments or homework for the students. So example 4 is like this. Evaluate integration over c 3z minus 4 divided by z into z minus 1 into z minus 2 into dz, where modulus of z is equals to 3 by 2. So answer is minus 2 pi I. And next example is evaluate integration over c 2z cubed 1 divided by z plus 1 whole square into z minus 2 into dz, where c is circle and the first one is modulus of z is equals to 3 and the second one is modulus of z plus 1 is equals to 1. So the answers are for first one 4 pi I and for second one 2 pi I. Please try to solve these two problems. These two problems are very important, and if you have any doubt you can comment by below. Thank you.